Hey, welcome everyone to the daily practice. So today our focus is the three questions that were posted about 23 hours ago. We have the easy question, the medium question, and the hard question. If you haven't actually joined us, please join us at sdskills.com/slack and join the #Leetcode practice channel. All right, with that said, let me resume the screen share. And share application window. All right, so did you guys able to see my screen?
Yeah, you can see.
Okay, fantastic, awesome. So the first question that we have is essentially N-ary Postorder traversal of an N-ary tree. Anyone who's tried solving this? So it's like we know how it works for a binary tree, but this is just a N-ary tree. Where how would you actually store the children in a binary tree? Anyone? Go ahead, Smita.
Like it's in the form of children, left child and right child, right?
So we do left child and right child. They're actually named children in the case of a binary tree. But in the case of an N-ary tree, there is no left, there is no right. They're just children, right? They're all the children, 1, 2, 3, 4, 5, or whatever. So how would you do post-order traversal in that case? The concept remains the same, right? A post-order traversal is where you traverse all the children before you traverse the parent, and that's pretty much what it is. So the expectation will be that you will be, in this case, you'll actually have to traverse all the child elements. Anyone who's actually written code for this?
So I think it is same thing in do as a binary, and instead of left and right, in this case, basically we go through all children before we.
That's it. Simple for loop with all the children, right? In a typical post-order traversal, right? There is no concept of, like, left, right, and then right, left. Like you just transfer. You just have to finish all the children. That's it. So the only catch here is that the input is represented in the level order traversal with null whenever there is nothing. So I think the tree reconstructions is a little bit of a pain. Each group of children is represented by nulls. So essentially, you just have to, like, reconstructing the tree will be a little bit of a pain. But actually, I don't see any concerns on this question. So anyone here who actually wants to share their code or talk about how they've been doing it? Has anyone solved this?
Yeah, I have solved it.
So go ahead. How did you solve it, Sonia?
Sure. Let me share my screen, or I can explain over here.
I may have to stop share. You can share it. Go ahead.
Okay. So can you see my screen?
Yeah, we can. Go on.
So the thing what I am looking for it is like we need to put like the children's first, but it in a reverse order. So here it should be like the stack. Whenever we need to put something in a stack, it should be in a reverse order. For example, first of all 1, then 4, 2, 3, and then 6 and 5. so that
Go
when
on.
we pop something, then it should be like how we can pop easily the which is at the top. So based on this, so what I just take a stack and put a node of root, which is 1, and when I pop the 1, I I append that on a first place, which is at the 0 place of the result. For example, here my I have a result set, and I have put here 1. Can you see over here where I have say
Yep.
check the result?
They can see you.
And so now I need to traverse the all the children of those of that node, which are like and my stack now would look like it. My stack would look like this. It should be having 3, 2, and 4.
You push 3 first, then you push 2, then you pushed 4.
Yes. So yeah. So the stack it's having 3, 2, 4. Like it's on a going from downwards to upwards or from left to right. Like 4 is on a top.
Correct.
And now when I again go for it in a stack, now I pop 4. Now I pop 4. Now my 4 is inserted at the 0th position again, which is like here. And then again it would check if there is no children, then it will again go high 2, and now 2 will be inserted at the 0th position. Like it will be in a appending in a reverse direction, I would say. And again 2 is also not having any children, but 3 is there. 3 is having their children. So first of all, 3 will be inserted at 0, and then its children would be like 5 and 6 in a stack.
And then you will pop out the 6 first, put it there, pop out the 5 first.
0th position, like it's appending at the left side, not at the right side. So again, pop 5, it will be like 5 over here.
Perfect.
Yeah.
So why did you choose iterative over recursive?
I am looking for iterative, like something like I am comfortable with iterative, I would say. And I know there would be something with a stack I can easily do. So that's why iterative I chose. Like I know there would be a stack option.
No, I understand that. So I think this is an iterative solution, and this is using stack. The only negative part of the solution, which actually makes it a little uncomfortable, is the fact that you have like you're actually you're adding the data from the back, so you're assembling the result in the reverse order. If you and you're processing it in almost the opposite order, right? And then you're putting it in a stack. You're putting it in a essentially what you're doing is the final one is a stack.
Yes.
Even though you're doing an insert first, right? But it's effectively a stack based thing, because you're outputting the data in the exact reverse order of which it is required. So it's a little weird, because if you wanted to do this for any computation purposes, like for example, if you wanted to do a post-order traversal because you wanted to calculate the cumulative sum of this entire tree, you will not be able to do that, because you've already processed 1 before you have processed 3, 2, and 4. Even though in the output you've done it the right way. So while this is actually accurate for this particular question, you may struggle if you're doing this for other reasons. So just be watchful. Do practice the regular stack, regular question, which is where you will be essentially what you are doing is it's a recursive solution, right? You will take the first element, process all its children, like you'll recursively call process on the children, and then you will just call the process self essentially, and that's like a 4-line 5-line code.
Okay. Yeah, so that will also work. I know. Yeah.
That's the easier algorithm. So I think we can definitely move on to the next question at this point. But But this is like a very interesting approach, and this approach works, and
So
it's
I have a
accurate,
question,
and I
like,
think it will work in all cases. Go ahead,
like
Sonia. Sorry.
there is a question like something if we need same question with the pre-order.
Hmm.
So like if we need to print as a pre-order thing.
If it's a pre-order, then I think it's the same, right? You would actually just, instead of doing insert first, you would probably do. I mean, recursion makes it easy. You can just process node, and then you can process the children much easier.
Mm-hmm.
But if you were to do something similar, I would assume you will insert that not in the 0th position, but in the end of it. Anyway.
At the position or like yeah, simply appending.
Yeah, simply append will work. And the
Yeah.
only other thing that you would do differently is, I think that's it, right? That's it. If you just append at the end, you just pre-order, right?
But I think then I need to append in a stack in a reverse way. Like first of all 4 2 3 instead of 3 2 4. How I am appending. Like my children's would be in a stack should be in a reverse way. Thinking like that. Because then on a pop I'll be getting 3 first. Something like that. So if it's 1, then I know something like if hello. I'm not able to hear you.
I'm there. I can hear you, Sonia.
Okay.
Yeah.
So so it's like if I need to append in a I need to do it that in a pre-order, then it should be like I have written something 1 here,
Mhm.
and then while append in a stack, I should append in reverse direction, which is like 5 2 3, and then if I 4 2 3, sorry, like when I remove 3, it is appended over here, then and then its children's are 6 and 5, then 5 will move and it would be here,
Then instead of stack, you can take a queue.
then 6, yeah, I think I have erased 2 over here, but then 2 and then 4, it's like that. Like it's simply like, but the only trick is either we can take a queue in here or a stack, like it's up to us. Like queue would also work because we are if we are making it in a queue, then we are pending 3 2 4, then the first one would remove like 3. So instead of stack, I thought because it's a same version of that question. So I have taken stack, so I tried with stack.
Also, the question said iteratively, right? To do it iteratively. Is that the reason why you did it iteratively?
Yeah, maybe one. Yeah, I have taken iteratively also. It's written iteratively as well. Mm-hmm.
Hey, my audio bridge kind of gave out, so I'm just dialing in from my phone. So I was following along what you're saying, so yes, this is good. Just trying to see if there were others who had any other questions on this specific question. We can move on to the next one otherwise. I mean, this approach is fantastic, and this works. And I think we also have, the good thing I like about how you've thought about this is also, you're thinking about how do I extend this question in terms of what if it was pre-order versus post-order and things like that. There is no concept of in order for an N-ary tree because there is no middle, right? It's a little hard to figure out.
Yeah.
Okay. And you can always do level order traversing as well for this one, which is like a simple breadth first search. So in that case, you will just.
Yeah, that's a good approach, an easy approach.
Yeah. All right.